Welcome back. So, multiplication or division of signs. Sign change occurs only in the multiplication or division of signs or numbers with signs. Here we have a few set of problems that we can try out. But before we do that, let's take a quick review. For multiplication or division, if you have two positive numbers, positive times a positive will always give you a positive number. Once again, for multiplication or division, if you're multiplying or dividing two negative numbers, negative times a negative will still give you a positive. Or, another set, what if we have a positive and a negative number multiplying or dividing with each other? Well, if you have a positive times a negative, in this case it'll give you a negative. What if we have a negative being multiplied or divided by a positive? Well, in this case it will also give you a negative. So probably the easiest way to remember this is that if you have two numbers that are positive and multiplied or divided, the answer is a positive. Two numbers that are negative being multiplied or divided will give you a positive. So when you're multiplying or dividing and they have the same sign for the numbers, you get a positive answer. On the other hand, if you have opposite signs on the numbers, one's a positive, the other one's a negative, or one's a negative, the other one's a positive, you're going to get a negative answer. Okay, let's try A. So on A, we have negative 1 times negative 3. 3 times 1 is 3. Notice that the quantity is not depending on the sign. It still gives us 3. And now for the negative. Negative times a negative, well, two repeated negatives. Since it's the same sign and it's being multiplied, it's a positive 3 overall. So our answer, positive 3. B. In this case, we have negative 1 times 3. Notice the parentheses implies that it's a positive 3, and we're multiplying. Parentheses always implies multiplication if there's nothing between the number and the variable or number and a number. So 1 times 3, quantity is still 3. And now that 1 is a negative, 3 is a positive, so two opposite signs. Negative times a positive, two different signs, gives us a negative. So our answer is negative 3. C. 2 times 3 is 6. Quantity-wise, we still get 6 no matter what. But both positives, 2 times 3, still gives us a positive 6. Both positive numbers. D. 4 times 5 gives us 20. And now for our sign. Negative 4 and a positive 5, two opposite signs. Negative times a positive will give us a negative. So it's a negative 20 for our final answer. E. Once again, 4 times 5 is 20. And now notice, we need parentheses around the 5 because there's a negative. This represents that there's multiplication between the 4 and the negative 5. So, two opposite signs being multiplied. One's a negative and one's a positive. Or should I say 4 is positive, 5 is negative. 4 times 5 is 20. Positive, negative, still negative. F. Once again, it's for multiplication and division. So in this case, a fraction implies division, right? 8 divided by 4, quantity is 2. Always try dividing, see if you get a whole number first. The 8 is positive, the 4 is negative. So two opposite signs will give us a negative. In this case, a negative 2. G. 8 divided by 4. Well, we can write it with a fraction sign, as in with F, the F problem. G, I've written it with a slash, or G, as shown in the slide, with the division sign. They all imply division. So 8 divided by 4 is still 2, and they have opposite signs. One's negative and one's positive, so negative 2 is the answer. H, 6 divided by 3, quantity gives us 2. two negative signs, they're both negative, so negative times negative is a positive. We have positive 2 as our answer. And finally, I. Negative 2 divided by negative 4. 2 divided by 4, well, all we can do here is simplify. They're both multiples of 2 because they're even numbers, right? So half of 2, because it's a multiple of 2, half of 2 gives us 1, and half of 4 gives us 2. Or likewise, you can divide by 2 if it helps. Negative times negative will give us a positive. So our answer is a positive 1/2. Decimal wise, 0.5, right? But let's leave it as an exact value for now.